Hello and welcome to the Unit 7, Section 1 video on exponential function, key features, and transformations. So let's talk about what an exponential parent function is. An exponential function is a function containing a positive numerical base not equal to 1 taken to a variable power. Now the reason that the base cannot be 1 is because if we take 1 to any power, you just get 1 and nothing changes. So we need to have the base be something other than 1. And we also cannot let it be 0 because 0 to any power just gives you 0 in return. So we can't let it be 0, we can't let it be 1, but the base can be just about anything else. So here is a look at the exponential parent function. And in this exponential parent function, our parent function is actually b to the x, where b is whatever our base is. It can be any number other than 0 or 1. But we can't really graph anything that way. So for example, so we can graph something, we're going to use 2 to the x. Our base is going to be set at 2 so that we can actually see what this looks like on a graph. So let's start off with 0. 2 to the 0 power, if you remember your rules for exponents, anything to the 0 power gives you 1. So 2 to the 0 is 1. All right, now we go to 2 to the first. 2 to the first gives you 2. 2 squared gives you 4. And 2 to the third, or 2 cubed, gives you 8. Now think about 2 to the negative 1. Well, 2 to the negative 1 is just 1 over 2 to the first, because remember your negative exponent rule, if it's in the numerator, you got to take it down to the denominator to take the negative sign off. So what we have here is 1 over 2 to the 1, and that's just 1/2. For negative 2, that gives us 2 to the negative 2, which is 1 over 2 squared, which is 1/4. And then 2 to the negative 3 is 1 over 2 to the third, which is 1/8. So we can plot our points here on the graph, and we have 0, 1, 1, 2, 2, 4, and 3, 8. And then on the other side, we have 1/2, about 1/4, and about 1/8 at negative 1, negative 2, and negative 3. And so we can draw our function through these points, and you get a function that grows rapidly on one end. Okay? Now I'm going to try to redraw that so it looks a little bit better. So there's a look at the graph for an exponential function. Okay, so again, you notice that it moves rapidly upward as you go to the right. Okay, so now that you have your graph sketched, let's use that to pick out some of the key features. All right, the x-intercept. Well, we approach the x-axis, but we never quite cross it. So we actually have an asymptote along the x-axis, because as this number gets smaller and smaller on the bottom, we get a bigger and bigger number, which means we get closer and closer to 0. So there are no x-intercepts. Y-intercept, we have one at 0, 1. The domain is from negative infinity to positive infinity, because remember, for domain, you look left to right. The range is from 0 to infinity. And then the graph shape, here we have growth. The other option, if it were going downward, would be decay. And we'll talk a little bit more about that as we move a little bit further along in this unit. Positive interval, well, all of these values are positive, so it's negative infinity to positive infinity. Since everything's positive, we have no negative intervals. We're increasing from the left to right the whole time, so therefore we're not decreasing at all. And then for the end behavior, as x approaches infinity, f of x also approaches infinity. And as x approaches negative infinity, that's on the left-hand side, we're getting closer and closer to the x-axis, so f of x approaches 0. Now, let's talk about these last couple of points here. Notice that as the x values decrease, the graph of the function gets closer and closer to the x-axis. So we've already mentioned that. And if you think about it, the function never reaches the x-axis because the value of 2 to the x cannot be 0. No matter what you put in for x, you're never going to get 0 out of it. So in this case, the x-axis is an asymptote. And we talked about asymptotes back in Unit 5. A function of the form f of x equals ab to the x, where a is greater than 0 and b is greater than 0, is an exponential growth function. And when b is between 0 and 1, you have an exponential decay function. And again, we're going to talk more about those functions a little bit later in this unit. All right, so let's talk about exponential transformations. This is the last time that we are going to go through transformations. And just like every other function that we have done in this Algebra 2 course, everything behaves the same way, okay? Now, the form that you see here gives us hk, and that is the translation of 0, 1. Now, I think it's going to be a little bit easier just to translate the entire axes, the entire x and y axis, and draw our graph from that vantage point. And I'll show you how those work as we do example 2. But in the meantime, let's just talk about what these rules do and how they look. And this again is one last time. So let's take a look at the horizontal translation to the right. That happens when h is positive. And as always, that's the value that follows x. So you've got f of x equals 2 to the x minus 2. Okay, that would be a horizontal translation 2 units to the right. If h is negative, then you would have something that looks like 2 to the x minus negative 2, which, as it did before, makes it look positive. So that's a translation to the left by 2 units. All right, translations up and down. That is the number that follows at the end. So in this case, you've got 2 to the x plus 4, not in the exponent. And in a translation down, 2 to the x minus 4 is an example of that. For a reflection across the x-axis, a is negative. So whatever your leading term is out in front, you're going to have a negative out here in front. And if you want a reflection across the y-axis, you're going to put that negative sign in front of the x. And then for a vertical stretch, you're going to have f of x equals some number greater than 1 for a. So you're going to have 3 times 2 to the x. And then for a vertical compression, f of x equals something like 1/3 times 2 to the x. Now, note on these, we cannot combine these numbers because this 3 does not have a power of x on it like this 2 does. So they have to stay separated. All right, knowing all that information, let's identify the transformations that occurred to the exponential parent function for these different functions. So for a, we have been translated to the right 4 units. That is indicated here. And then up 3. For b, we have a reflection across the x-axis. We also have a vertical stretch of 3. And we also have a translation to the left by 1. For C, we have a vertical compression by a half. We have a reflection across the y-axis. And we also are being translated down 8. And then finally for D, we have a reflection across the x-axis. We also are translated left 7 and up 5. So all of this behaves very much like what you're used to from all the functions we've already done. All right, now let's take a look at example 2, where we are going to graph the function, and then we're going to identify the key features. So first of all, let's graph this thing. Well, to graph this, we need to know what our translations are. So for this one, we are translated to the left 3 and down 5. So I'm going to actually move my axes by those amounts. So if we're moving left 3, I'm going to move my y-axis to the left 3. And I'm just going to draw it here in green. And we're going to move our x-axis down 5, which would place it here. We've got no stretch, we've not got no compression, we've got no reflection. So we're going to graph the parent function based off of this new axis that we just drew. Now keep in mind, these green lines are just guides so that we can plot the function. When you do all of this information that's over here on the left, you're going to read that from your original axes, okay? These green lines are nothing more than a guide, so we draw our graph in the right place. So our first point, 2 to the 0 gives us 1, 2 to the first gives us 2, 2 squared gives us 4, and then 2 to the third gives us 8, which puts us here. And we can go ahead and draw our function based off of those dots that were plotted. And so our function looks basically like this. All right, so let's talk about some of the key features. Increasing interval. Well, that's happening everywhere. It's increasing from left to right the entire time. It's decreasing nowhere. The domain, left to right, all reals. Now the range, our asymptote is at -5. So we go from -5 to infinity, from bottom to top. And then for our end behavior, as x approaches infinity, f of x also approaches infinity. As x approaches negative infinity, we're getting closer and closer to -5. So f of x approaches -5. All right, let's take a look at b. So again, we're going to move our axes based on our translations. So we're going to the right 1, so that happens here. And we're going up 6, which places our axis here. Now we're going to plot our points. Now here we're reflected, and we're reflected across the x-axis, which is this one that we drew. So instead of going up, we're going to go down. So 2 to the first is 1, but we're going to go down 1. 2 to the first is 2. 2 squared is 4. 2 to the third is 8. And so we can draw our function from here. So my drawing's a little rough, but it does get the point across. So our increasing interval, well, this whole thing is decreasing, so therefore there's no increasing interval. And since it's decreasing everywhere, we put negative infinity to positive infinity. Domain, again, all reals. Range, this time, goes from negative infinity at the bottom end and goes to 6 on the top end. End behavior, as x approaches infinity, f of x is going to negative infinity. As x goes to negative infinity, f of x is going to 6. And now for the last of these 3 examples. We've got f of x equals 2 to the negative x minus 4. So again, let's talk about what is happening with our translations. So we've got nothing following the x, so it's not moving left or right at all. So your axis is going to be right where it is for the y. Let me draw that just a little bit better. And then for the x-axis, we are moving that down 4. So that puts it here. So now, Let's draw our points. Well, this one is being reflected across the y-axis, which is right here. So instead of going forward, we're going to go back. So first we start with 0, 1, because 2 to the 0 is 1. 2 to the first is 2. 2 squared is 4. And 2 to the third is 8, which puts us here. And so now we've got enough points that we can draw a sketch of our curve. So that's what our curve looks like. Now let's pick out some of the key features. This time, x-intercept. Well, this one does go through the x-axis at -2, 0. The y-intercept, that's going to be at 0, -3. We're positive from -infinity to -2. We're negative from -2 to positive infinity. Our domain, -infinity to positive infinity, as always. And our range, we start on the bottom end from 4, and we work our way up to infinity. And those are your key features for this particular function. So that's going to do it for section 1. That goes over our key features and our transformations. This is the last time we're going to have to deal with transformations for a new function in this course. As we move on into section 2, we're going to start talking a little bit about the characteristics of exponential functions, and we'll be doing that by talking about geometric sequences.